Alright, I'm starting up the stream. It should be going shortly. Looks like it's running. Hi everyone, I'm TigerHawk3, and today I'm going to not code anything, but tell you about what I already coded offline because it was messy and kind of annoying, and it took a few hours. So I've skipped for you the portion where I got everything wrong, and now we have arrived at the part where everything is correct, I really hope. So, one of the key changes that I made is I add a flag to say if our deck is the original direction or backwards. Because remember, the nodes are all created with a next and a prior. So if we reverse it, then going forward means using prior instead. So this should help determine that, and we don't have to kind of iterate through and see if the node after the one we just did is the next one or the prior one. So, and this is our deck, by the way. This is a multi-part stream, several videos. The previous ones are on my channel. You can watch them if you want. The code is on GitHub, and yeah. So I have a flag for whether we're going forward, which is the original direction, etc., etc. We already had these. In reverse, this is where I make a clever hack that gives me a lot more work, right? I switch the iterator directions, the pop directions, and the append directions, and here I added switch forward to being the opposite of whatever it was. Okay, here are a couple helper functions, which I will explain. I'll explain this one first because it shows up here, so I'll need that. This gives me an index of my deck that I can use, kind of normalized, norm index and normalized index, because I might pass a number outside the range of negative quantity to positive quantity -1. So if you have a deck, any sequence really, with a length of say 10, the valid indices range from -10 to +9. So if I'm past something outside those ranges outside that range, or even a negative value, this will turn it into something very basic and standard, like you could use this number to access an array in like C or something. And this will, like if someone passes -1 for the last item, this will turn it into length -1, basically. And if someone passes something, a positive number longer than the length of the array, then it also does that. It trims that down. And yeah. So this min and max stuff, I take the index I was passed and the negative quantity, so if it's length 10, then this would be -10, and I take the larger one. So taking the larger one, when we want to establish the minimum bound, is kind of unintuitive, but that is how it works. So if we get -12, and the most negative index that makes sense would be -10, this will bring it up to -10. And same thing with min. After we've established that it's not too small, we have to establish that it's not too large. So our quantity in our example being 10, if we're past 20, then this would bring it down to 10. GoScript in chat says TigerHawk3 is back. Yes, I am. I was not gone for very long, a week, 2, I don't know. I've been meaning to stream this for a few days, so, and I fixed it, so I'm gonna tell y'all about it. So that's norm index returns a normalized index, something we can work with, that gives us something between 0 and the length of the array, not length minus 1, because that's a different case that I had to account for, because if you insert something at an index of the length of the deck or more, then it shows up at the end. So it's not necessarily before some item. Of course, if you do that, it would make more sense to just, append. But this is how Deque should work, so it's going to do that. Now, distance to index, the point of this method is to help with the rotate method. And it converts a distance of rotation, how many elements you want to cycle around, and converts that into the index of the item where we're going to cut our deck and put something on the other side. That's what that does. I take the modulo of it, I make it negative, and I get a regular index out of that. And I have to make it negative because the way that positive and negative rotation works is rotating by 1 means that the item you're interested in is at -1. So here's the array, or the deck, and here's the beginning, and here's the end for you. So if we say rotate by 1, then that means just the last item here. We're going to take that and move it over. So this item is at index -1, not +1. So that's why we make that negative, and then we do norm index. So it'll get, instead of a negative number, we'll have, the length of the deck -1, -2 actually. So that's the purpose of that. Another helper method that's so large it barely fits in one screen. It fits in the screen when I make this full screen for me, but I have it slightly smaller so it's easier for you to see as a video. Okay, so this neighbors method, I have an underscore which indicates that it's not intended for the end user to use. They can access it if they want, but it's not suggested. Like, this is for internal stuff, not really part of the API. So this gets an index, number, and then normalizes it, and it should return the item at the index we were passed, and also the item before it, and the one after it. And by item, I mean the node, not the element within the node. Because this is going to have, we're going to get the next and prior, etc. of these things. So this is the node that we're going to get. If not self.quantity, meaning if it's empty, if the deck's empty, the one before the node itself and the node after are just none. So we'll say, we'll be able to check if before or after is none, or this, etc. It's going to be useful. If the index is equal to the quantity, which means it's after the maximum deck. So if we have our deck of length 10, the maximum valid index is 9, but we were passed an index of 10. So that means this is the last item. It's over here at the end, which is a certain thing. So it means that we need the item before is the last item in the deck, and the item itself is none. And the one after that is also none, of course. So we do, we iterate backwards because it's at the end, it's faster to go from that direction. And we get the next item of that iterator, and that's the item before, the first item from the end. So we return this, and none, and none. Actually, I could have done just return next it, none, none, instead of saving before. Let me write that down. That will be a change that I can make. Return next it. No, okay. I have duly noted it. So if we have exactly one element in the deck, then it's just note that this is one element in the deck and our index isn't after that item. So that means there's always an after to this, except if there's exactly one item in the deck. Do I have this right? I'm still not sure, because it's a pile of off by one errors, and you know, it's a shell game. Things move around and you're looking at it from the other direction. You know that if you've seen that South Park episode where the police are trying to catch a serial killer or something, and there's like montages and stuff, and the killer always like cuts off the victim's hand, and they have to investigate, you know, that, and so they see they actually find the guy and he's got like hands, but he says, no, these aren't left hands, these are right hands, so it's fine, or something. They're not very smart. So at one point, one of the detectives is like looking at his hand because he can't really figure out, if it's going like this, is it a left hand, or is that a right hand if I turn around? So it's a whole bunch of that. So at this point, we have established that there's at least one element, and we are at some point, our index is not after the very end. So if we have exactly one item, and we're not looking at the point after it, then it would have to be the point before it, which means it itself. So we have nothing before, nothing after, and here's the node that we want. If not I, meaning if the index we got is 0, means there's nothing before, and after this point we know there's at least 2 elements, because this would have returned already if it was 1. So we've got none, and the first thing from the iterator, and the next one. And that's that part. If I is the last element, not after the last, but actually the last, then we start from the back. We get the last element, that's the current thing that we want, and then we want the one before it. So we continue going backward, and so we've got the one before it, we've got itself, and there's nothing after. And after this point, we're just looking at somewhere in the middle. There's going to be no nones in the result. So this means if it's closer to the beginning, and this is if it's closer to the end. So if it's closer to the beginning, then we want to start at the beginning and go forward. Otherwise, we will start at the end and go backwards. And we either go, you know, this amount, or, you know, the difference of the length for that amount. So if our length is 10 and we're at 2, 2 is less than, you know, 5, so we go forward. But if we got 8, then we would do this instead, and we'd do 10 minus 8 minus 1, which is 1. Yeah. And that would be that. And so we get the item before. We just cycle through a bunch. Then we say, okay, now that we've gotten to the one before, we have, we can calculate the current one and the one after that. But if we're going backwards, because it was faster to go from the end, then we say this is the one after that we get to, and then current and before, just going backward. And that is the neighbors helper method. Now we can do things with it. Yeah, we use that. It's good. Good helper method. That's a good helper method. Good job. Anyway, so if we insert, means we've got our node, and I forgot to put one thing in this before I pushed it, and that is adherence to the max len property. If you have a maximum length for your deck, if you append something to it, it should pop something from the left, and if you append something to the left, it should pop something from the right. But if you insert into the middle, what is it supposed to do? That behavior is undefined. I don't know what it should do. So the actual implementation of this, the standard library, raises an error. So next stream, I'm going to make it raise an error. And that'll be, you know, up to spec. So we make a node out of our element. We get the neighbors. So we have the element before, the element itself, and the element after. Sorry, the node before, current, and after. Now we need some handling. If current is none, meaning we're at the end, we passed an index equal to, greater than or equal to the length of the deck. So there's something before, but nothing current, and definitely nothing after. So in that case, current is none, right? We're just going to append the element, because that's inserting onto the end, and then we're done. Otherwise, it's somewhere before some element, before an existing node. So if we're going forward, if there's a node before, then that one points to the node that we made. Otherwise, the first is now the node we just made. If there's a current, then the one before it is this node. Otherwise, the last one is this node. Pretty self-explanatory. It only took me like hours to, yeah, no. So basically we have the node before the one we're interested, the current one, and the one after. Do I use after? I do not. I only use before and current. So, there's bugs flying around. That's great. I got it. Delightful. And ew. I think I mentioned before that this is not a vegan-friendly stream. Apologies to my vegan viewers. But bugs are not okay. Does this still work? I don't know. Sort of. Great. So, I'm interested in before and current. Current is the index of the element that we're interested in. So the node that we insert, the new one, is going to go between before and current. So if there's something before the node we're interested in, then that node is going to point to the one we're adding. And if there's nothing before, then we're just adding to the beginning, meaning this is going to be our first node. Actually, if before... this can just be append left. there's one, if before, we want before.next equals node, and node.prior, node.next equals before and current. Yeah, this is an actual insert. But if there's nothing, then we just want to say append left. I will make a note of that too. In insert if not self dot first or not self dot last should be appends. Append or append left as necessary. These are things we will do next time, not now. I'm trying to keep it one stream, one commit. So this is going to change. If before, so if there's something before, then we'll, you know, do stuff there. Otherwise, we'll just insert it. If current, so if there's no current, then this should be an append. This should be append left, and this should be, this is an append left situation. This is an append situation. That's easier, I think. I mean, it's not really any different. I would just be moving this into here and here. And these lines would change to, you know, append and append left. Does that make any difference? I don't know. Is it better to use append and append left? It might be, even though it'll be longer, just for clarity. I could do if before and current. Then I'd have to check for before and then current. Might as well just leave it this way. But keep in mind, this is equivalent to append left. And this is going to be equivalent to, I mean, this thing, and this line, and this thing. Together are equivalent to append or append left, minus the maxlen handling, because if they violate maxlen, then then it should raise an error, and it doesn't matter. It doesn't have to do this thing. First, last, etc. Yeah, doesn't make much difference. Okay. Insert. So if we're going forward, before, same thing. Here we want next. Here we want prior. And the else, first or last. Here of current, current.prior, as opposed to current.next. Last, first. Next, prior. Oh, and prior and next, as opposed to next and prior. So we just invert all those, because the next and prior are not things that we can swap easily when we do a reverse operation. Now rotate, that's pretty short, that's good. The easy way would be just getting a number, and then if it's positive, do, you know, that number of pop and append left, or pop left and append, I don't know. And if it's negative, do, you know, the inverse. Instead of pop, pop left. Instead of append, append left. That would be the simple way. But I wanted a faster way, because Python is already kind of slow-ish. So instead if the quantity is less than 2, meaning it's empty or there's only one item, then no amount of rotating will make any difference, so we just return. It's done. Otherwise, we will need to find an index of where this is our distance to index. We have our distance of how far we want to rotate it, and we want to find where should we cut our deck. What element index is gonna have stuff happen to it. And then if it turns out that there would be no change, meaning the index is 0, because if we have our deck, and the index 0 is, the first one, so before that, then rotating the whole thing, there's no change. So we return. So we're done. Otherwise, it means we will have to change something. So we're going to find the one before, the current, and the after with our handy neighbors method. So if we're going forward, and here's if we're going backward, so we're going to get, it's just a whole bunch of swaps, basically, because we have our deck, and we've decided, say, we want to rotate with this as the rotation point. So we're going to go whoop, and that means basically cut here and then connect there. So here's where we do that. We need to change our first and last references, and we need to say the ones that used to be here in the middle, that this one pointed to this one and this one pointed to that one, they will now be the beginning and end. So they will point to nothing on one side. And we will have a new first and last, and our previous first and last will now point to things. So this does that. Why are these the same? Next, self dot first dot prior, self dot first, self dot last. I guess that's the same. Yeah, I guess that's the same one. Because last, next, prior don't care about direction. I will write that down. In rotate, move self dot last dot next, etc. references to be reassignments to be unconditional because they're the same in both. If you have an if and an else and they're the same, you can move it out of the if statement. I can put this before here, and then I will be able to save a line. So we do that. Before dot next. So here we have before, and the before, current, after don't know whether they need next or prior in them. That's why we're checking if self dot forward. So here I do next. Here I do prior, here I do prior, here I do next. And here I'm using current and before again, right? So those have to be different with first and last. First and last, last and first. And that's how that's done. And here's my testing thing. I make if you had just opened this module and started looking at it, and the first thing you see is import collections. Oh, you just import collections and then make a regular deck. Haha. No, I'm not actually doing that. It's just for testing. So I have a canonical collections.deck. So I do various things, reverse, and do some inserts. I already tested rotate. So this was my more recent thing, reverse, and do some insertions, and if one is not equal to the other, then print what they are, so I can see what went wrong. And then, oh yeah, here we are, rotate. So I do some reversals and insertions and rotations and reversals, and if they ever turn out different, then it'll print something. But if not, it'll just not have any output. And last time I ran this, it didn't have any output. I'm like, fantastic. So, half an hour. Perfect. I was hoping this would be a short stream, less than half an hour. My standards for short and long are a little bit odd, but that's okay. So, this works. And next time, I'll add an exception for trying to insert into a deck that's already at the maximum length. I'll move that those reassignments in rotate out of the branches because they're the same in both. In insert, I'm not going to change those things to append or append left because it wouldn't actually save any effort. And I can return, instead of saving the before in neighbors, where the heck is neighbors? Instead of this stuff, I can just return next it none none. I don't need to save this for any reason because I'm already returning right here. I'm not doing this at the end. And other things that I will be doing apart from these tweaks include implementing a contains method, a magic method, also known as a special method, that starts and ends with double underscore. So that'll allow us to say if some value is in our deck, then, you know, so that's just the in operator. You can also do if deck dot underscore underscore contains underscore underscore the element, but just the in operator is easier, and it will call this method automatically. So we'll implement that. I decided that I want a replace method, similar to how strings you can do replace. There's a replace method. The difference will be in strings, if you replace all instances of an element with none. Actually, I think I have, is it the delete? Yeah. Remove. So, with strings, if you replace a substring in a string with an empty string, then it'll basically remove it, because the first part of the string plus an empty string plus the rest of the string is just, you know, the string with that part removed. But if you wanted to remove an actual node, then you'd need to, you know, remove it and change the pointers to skip it. If you replaced it with none or nothing, you would just get a node that points to none. So it's not a thing. If you could guarantee that you would only be working with, for example, strings in your deck, then you could say that remove just makes instead of all this stuff, you could just say that the element is now an empty string, and then you could like join it or something later, and it wouldn't make any difference. Actually, yes, it would, because those empty strings wouldn't disappear. So yeah, doesn't quite work the same. I added this dealy. Note that all is the name of a built-in function in Python, but I'm not using it in this method I mean, I'm not using that function in this method, so it's okay-ish. What this does is remove the first occurrence of some element, and that removes the node holding the element. And if you pass a truthy value for all, it'll keep going through the deck and remove all of them. So that would be equivalent in a string to replacing with the empty string, and that would just remove everything. But I also want to have a replace method that replaces all elements. It looks at every node that contains a certain element and replaces that element with your new one. And I'll probably have an all as well for that. So you can maybe a quantity. This should be a quantity instead. How would I do that? Maybe this one can stay with just only one of them, or all that you find. And the replace, because string.replace actually does have an option for how many to do. S.replace old, new with an optional count. Return a copy of S with all occurrences of substring old replaced by new. If the optional argument count is given, only the first count occurrences are replaced. There we go. Is there a replace right? I know there's like find and rfind. Replace, rfind, rindex, rjust, rpartition, rsplit, rstrip. There's no replace. Okay. Maybe I could do that. Okay. So we'll have a replace from each end. Maybe it would be better to be negative. That would be interesting. If it's 0, it's everything. If it's positive, it's the first n occurrences from the beginning. And if it's negative, it's the first n occurrences from the end. That seems fine. Sounds fine. Replace old, new, count with 0 meaning all, positive meaning from beginning, negative from end. Neat. That'll be fun. We'll do those things next time. And of course, there's all the other special methods, comparisons, greater, less than, equal to. What else is there? A lot. Indexing, slicing. The standard collections.deque does not support slicing. This one's going to support slicing because I feel like it, if I can manage to do it, hopefully. Hopefully should be doable. So slicing, indexing, deleting items, and delete, to use the del keyword, is distinct from remove, because remove operates by value, and the del keyword operates by index. So if you had a deck containing the letter A, the letter B, the letter C, and you wanted to take out that that A first element, you would do either deque dot remove A, or you would do del d bracket 0 bracket. And I think that's mostly it for today. But there's a whole bunch of special methods, plus these tweaks that I want to do. Here, blah, blah, blah. Beautiful, great, those don't change. It's fine. I don't know about this, because it's more detailed, but you can't actually reproduce a node. It doesn't make sense to do that. That's why I literally have ... Yeah, I'm not too happy with that. The string is a string of the node, and the repro maybe it should just be the element. But the element could be none itself, I don't know. That's something I might change because it just can't possibly work. It doesn't make sense to print out the entire way to recreate a node. So yeah. Self.forward. Distance to index. Norm index. Neighbors. Underscore neighbors, I mean. It's kind of big. Insert. And rotate. That's not what we did today, but that's what we looked at today. And they work, as far as I've tested. If you test this stuff with something other than this, and you see that something doesn't work like it should, you can comment and let me know how you produce that incorrect result, and I'll try to reproduce it and see what's wrong, and then maybe I can either fix it on stream or offline, I don't know. So, thank you for watching. I am TigerHawk3. Like, comment, subscribe. There's going to be more of this later. And thank you for watching. Have a good one.